Hi ladies and gentlemen, and welcome to the cabin of Golf Bravo November Kilo Charlie and this tutorial video on how to use this, the Avionics stack. Now you'll have to bear with me, I'm trying to frame these shots with my iPhone by hand, but we are going to talk through each of these radio receivers, how they integrate and interact, and how to use them. So from top to bottom we've got the audio control panel, Navcom 1, DME, ADF and the transponder. So the audio control panel determines what it is that we hear, whether it's through the earphones or through the speakers. From left to right the controls are a dial which is placarded int vol, that's the intercom volume control, so that determines how loud whatever you hear through your own mic in your earphones is, or whatever your passenger says into their mic is in your earphones. So that sets the volume for that closed loop between the two headset stations. We've got a bank of duplicate switches top and bottom that correspond to the placards between them. The top bank of switches corresponds to the speaker and the bottom bank corresponds to the earphones. And whichever of those switches you push in determines what you hear either on the speakers or the earphones. So the placards are HF, COM1, COM2, NAV1, NAV2, DME, marker, ADF and auto. So if we were to switch that button in there, it's on the phone bank, so we would hear NAV1 on our earphones, and NAV1 is the VOR, it's the Morse code ident that would come out of a VOR if we tuned one using this box, which we'll come to in a little while. Each of these buttons can be pushed in independently and out independently, so in theory you could listen to everything all at once. Now you wouldn't do that, but you may need to listen to 2 or 3 things simultaneously. So in order to hear whatever it is you want, whether it's the HF radio, which this aircraft doesn't have, COM1, which it does have, COM2 it doesn't have, NAV1 it does have, NAV2 it doesn't have, DME it has, it doesn't have markers, and it does have ADF. If you wanted to listen to any of the things this aircraft has wired into it, this is the button that you would press correspondingly. Now if you want to hear any of these oral channels on the speakers, you just press their corresponding button on the speaker bank. So if we wanted to hear NAV1, that's the VOR, over the speakers, we push that button in. On the right hand side we've got the transmission selector. It's placarded off, HF, COM1, COM2, PA and EXT. The off position is self-explanatory, that means there's no power to the audio control panel if you've got off selected. You won't do it any damage by leaving it selected to, as it is at the moment, COM1, and leaving power on this when you start the aircraft up or shut it down, so that's fine, you don't need to switch this one off. The HF position is not relevant because we don't have HF radio in this aircraft. COM1 is relevant because we do have COM1, we don't have COM2. PA is the station that you'd have if you've got a great big cabin behind you and this audio control panel's in perhaps something like a little jet stream or something like that, and you've got passengers to talk to. That would be your public address station. And the EXT is for an external channel, but there isn't one wired onto this panel. So the only position of relevance to us is where it's set now, which is COM1, and it can be left in that position. Now that is the transmit position, that's what we will transmit on. If you want to receive on COM1 automatically, then you must push the auto button in. If that auto button is in, then whichever of these stations is selected, you'll both transmit and receive on, but obviously COM1 is the only active one for us. And you could also back that up with pushing COM1 on the phone selection, so you'd hear it that way as well. But with the auto button pressed in and COM1 selected, you will transmit and receive on COM1. The next radio down is Navcom 1. This is the navigation side, this the communication side. Controls from left to right, with an on-off switch here, which we turn clockwise to power the unit up and further clockwise to set the volume. That flip-flop switch switches active and standby frequency positions around. This is our frequency controls. We've got almost duplicate controls on the right hand side for the navigation element, except this isn't an on-off switch, it's just a volume control, and that button also pulls in and out. We've got a flip-flop switch and we've got the frequency controls. So if you can bear with the noise, because we don't have the circuit breaker pulled for the turn coordinator, when we power the aircraft up it will spin up. To switch this unit on, turn that dial clockwise. Now we can see frequencies in the window. Active frequency, standby, active, standby. This is communication frequencies. This window shows navigation frequencies for the VOR. Now the first thing to do is set the volume. If the radio is receiving nothing because nobody's transmitting on frequency, then you won't be able to hear anything. But what we can do is we can select COM1 on the speakers so we can hear it on this video. And then if we pull this button, a little R comes up. We're receiving the carrier wave for the frequency even though there's nothing being modulated onto it. Now we can set the volume to a comfortable level. Then push that button back in. Now the volume's set, and when we receive anything from air traffic or another aircraft, it will be at a comfortable level. To tune a frequency, the large knob controls the numbers to the left of the decimal place, and the small knob controls the numbers to the right of the decimal place. And once you've selected the frequency you want in the standby window, press the flip-flop button, and that frequency goes across to the active window, and the active frequency then goes to the standby window. So we'll put Shobden back up. We'll set 121.5 for the D&D cell, and if we wanted that in the active frequency, we just push the button. The navigation side is very similar. At the moment we've got Honolulu selected 113.65, but because we're on the ground at Shobden we can't hear the beacon's Morse code ident. But if we were airborne we'd select that frequency and then we'd listen to the Morse code ident. Now, I'll just turn him down. That will turn him off. So, if we wanted to select Honolulu and listen to the Morse code ident, we would select nav1 on the earphones probably because we'd be airborne now. So we push that button in, we pull that button out, and then we set the volume to a comfortable level to hear the Morse code ident. Once we've received the Morse code, what we need to do then is deselect nav1 from the audio control panel, and that would silence this side of the radio. But with that button pulled out and the volume set at a comfortable level, that's ready to receive Morse code idents for subsequent VORs that we might want to tune en route. And when we want to listen to them, all we've then got to do is press nav1. Frequency controls and the flip-flop switch are exactly the same as they are on the communication side of the radio. The next radio in the stack is the DME box. The controls on the DME are on-off switch, which moves left and right, and a 3-position switch here, which is placarded remote, frequency, and that GS/T is for ground speed and time. This is the frequency controls, which we'll look at in a second when there's power on the machine. But just a brief discussion about this 3-way switch. The remote position, if you select it, will allow the box to automatically seek and tune the DME box that is co-located with whatever VOR you've got tuned in nav1. So for example, if we're using Honolulu, which is a co-located VOR DME, we'd have 113.65 in nav1 and we'd be displaying it on the VOR. If we push that into remote, then the DME box will look for the DME transponder that sits co-located with the Honolulu VOR and automatically read it. If you push the switch into frequency, that allows you to manually tune the frequency, and the situation we'd want that in is if we're looking at a DME box that's not co-located with a VOR. If we're looking at one on here, so typically if we've got Honolulu selected for the VOR but we wanted a DME range from Shawbury or from Brecon, we put frequency as the position for this switch and then we'd manually tune the frequency for the DME box we were interested in. The ground speed and time position gives you a readout of ground speed, which is computed from the decay of the DME as you're closing on it or pulling away from it, and the time function gives you a time to station. If we put power on the aircraft, we switch the unit on with that switch, and if we stick that into frequency, it's looking at 113.6, which is not actually a DME frequency in this country, but we've got nautical mile readout there, which is placarded because we're not in line of sight of anything here, nor are we actually tuned to anything, but that's where the distance display is. And to tune this frequency, we use these controls. The large dial controls the numbers to the left-hand side of the decimal place. The small dial controls the first of the decimal places when it's pushed in, and when it's pulled out, it controls the last digit. It changes it from 0 to a 5. If we select 113.65, that would be the Honolulu DME. But if we stuck that into remote and we got 113.65 selected on nav1, then this would automatically tune to 113.65. If we stick it into ground speed time, the frequency window is displaced by a knots and minutes readout. So that's the computed speed based on the DME count up or count down and the time to station. The next radio down is the ADF receiver. Controls from left to right are an ADF button which pushes in and out. BFO stands for beat frequency oscillation. There are no UK NDBs that use that anymore, so you won't need that in UK airspace. The frequency button changes the way the frequencies are displayed, and we'll look at that with power in a second. And these two buttons are in unison controls for a timer that's built into the unit if we want to use it. This is the on-off switch. Turn it clockwise to turn the unit on and further clockwise to increase the volume. The volume, of course, will be of the Morse code ident associated with the beacon that we're tuned to, and these are the frequency controls. If we turn the unit on, you can see that this is flight time. This counts up from the moment power is on the unit. We can't reset that. It's in ADF mode at the moment, and it's tuned to 426 kilohertz. To tune this frequency, we use these two dials. The large dial controls the first two digits in a 4-digit frequency, so you can see that's at 17. If we count down, once we go to a single digit, it then controls just that first digit. We'll set this back to 426 for Shobdon. The second digit is controlled with a small knob when it's pushed in, and when you pull it out, it controls the last digit. So we'll set 426 again. Now that's indicating the relative bearing to the Shobdon NDB, and that's about where the beacon is. If we push the ADF button, it switches to ANT, goes into a test mode which deflects the needle to the right hand wingtip. If we then return that to ADF, if that needle returns to a sensible relative bearing straight away, then that's a good test. The last thing we would need to do is check the Morse code ident. So we'd set the volume control low, we'd then select the ADF on our audio control panel. I'm going to put it on speaker so that we can hear it, and then we set the volume to a comfortable level and wait for the Morse code. Once we've idented it, we can then deselect it from the audio control panel. That silences that channel, but it's still ready to reselect when we tune a new NDB somewhere en route just by pushing that button in. The frequency we said changed the display. At the moment we've just got an active frequency, but if we push that button it gives us a standby frequency window. Now when we use these controls it changes the standby frequency, and if we want to make that the active frequency we just press that button. If we push that button it shows us the elapsed time since we powered the unit on, and if we push it again it shows elapsed time, and this one can be reset using this button. If you push that it zeroes it. Last radio is the transponder. Controls are a dial with off, standby, ground, on and alt. Off is fairly self-explanatory, that means there's no power on the unit. In standby the unit is powered but it's not transponding or doing anything. In ground it's not transponding but it can communicate with the flight level encoder for flight level reporting. When we switch to on, that's mode alpha, which will transpond the 4-digit code that we've got selected and the registration of the aircraft. And the last position, alt, will do all of that, plus it will transpond the flight level that the cabin is at. The ident button is what we use when we're asked to squawk with ident. So if air traffic give us a 4-digit code and ask us to squawk it with ident, we'd select the frequency and then we just push that button. The function button we'll look at with power in a second. The VFR button is a fast select for 7000. So if you've been working someone like Bryce and they've given you a squawk, when their service terminates they'll tell you to squawk 7000. Instead of manually selecting it, we can just press that button. That button there is to edit the registration that's transponded. You shouldn't need to set that, but if that's been misset and it needs correcting, then we'll show you how to do that. This is the frequency controls, and these buttons here are for built-in timer controls and also to cursor left and right through the frequency display. Put the unit into standby, it goes through a little built-in test. Tells us it's on standby. 7000 is the squawk that's ready to go. And Golf Bravo November Kilo Charlie is the registration that we'll be reporting. If we go into ground, switches to ground. It's now talking to the encoder for flight level information. It doesn't have it yet, but it will acquire it and then it will show it. At the moment we've got 1013 set on the altimeter and it's showing just over 200 feet. So we would be transponding flight level 002 for that. And if we have a look, the transponder's acquired it now. If we go into on, we're now squawking mode alpha. So we get the little transponder symbol, but we don't have anything in the flight level window because we're not reporting altitude. And then if we go to mode Charlie, it tells us we're squawking altitude as well, and it shows us what altitude it's reporting or flight level. Put that back into standby. The function key gives us flight time. This is a count up timer that starts once we start squawking. So if we go into mode alpha, that count up timer will start. The next function is a timer. You use the enter button to start the watch. Press again to stop. Press again to reset. To tune a frequency, we turn the dial. It puts a cursor over the first digit. We then select the number that we want, press enter, select the second number we want, press enter, and so on until we've selected our frequency. If you want to move back across the digits, you can use the back key so that you can correct the frequency if you've misselected. Once you've finished, press enter again and it will now be squawking that value. If you're assigned 7000 subsequently, you can just press the VFR button and it squawks 7000. That button there is to set the registration, and you set it exactly the same way that you set the frequency. So we turn this dial, that puts a cursor over the first character. You then select what you want, press enter to move to the next one, and so on. I'm just going to reset that. When you've finished setting the registration, just press that button